A very good morning, students. We are in our practical lecture, and this will be lecture number 4. And today we will try to solve map number 7. Okay, so here is the question: a thin coal seam having a dip of 14° north 35 east, outcrops at point P. Trace the outcrop, describe the topography of the area, comment on the trend of the outcrop. So this is the question, and you can see in the left hand side there is a northern arrow which is used for the reference of the direction, and here is the contoured map, and here is the point P which is mentioned as the location of the outcrop, and here is a scale which is 1 centimeter is equal to 200 meter, right? So this is what given, and the question they are mentioned as 14° not 35 east, right? So when they are mentioning it as 14°, which means this is the dip amount, and the not 35 east is the dip direction. Okay, so here they are given the dip amount and dip direction of the pole seam, and what we have to do is we have to trace the outcrop all along the map. Okay, is that clear? Okay, so let us solve in a regular way, that is, as you know, the formation is inclined. We have to trace the outcrop according to its strike, dip, and topography of the region, right? And we had solved map number 6, you remember, right? So whenever there is a equal value of strike and contour, there will be an outcrop. Okay, so what we have to do is we have to first of all trace the strike direction. For that, we have to trace the dip direction. As you know, the relation between the dip and strike is 90°. Okay, is that clear? So let us go to one after the other. We will solve the map just like in a regular way. So the very first thing what we have to do is we have to mark the dip direction, right? So for that we have to use the north reference from the map. As usual, we have to use the two set squares, the right angle triangle for the northern line, and we have to move it just like this, and we have to trace the line, and we have to mention it as N, which indicates this is a reference line which is parallel to the north direction. Okay, so then we have to do what we have to do is we have to mark the dip direction. For that we can use the protractor, and the question they are given as north 35 east, right? So this is north and this is east, so we have to point 35° which starts from north, and we have to move towards east. So this is 0, so this will be 10, 20, 30, and this is 35. Okay, so this is the north 35 east direction that we had pointed it using the protractor. After that we have to draw a line, right? So this will be the true dip direction, and we have to mention it as TD without any without leaving it, right? Because what happens when we are solving a map without mentioning the direction or any other details, this may be led to a confusion in our later stage, right? So whenever you are plotting a true dip direction, mention it as TD and only in the direction which they are given, not in both direction. As you know, the dip direction will be one side if it is a homoclinal series. If it is folded, then you can expect to be having two different direction dip, right? So for this map, it is having only one dip direction, which simply means it is a homoclinal series. Okay, so what else we have to do? So if you have a dip direction, you can plot the strike direction, right? So for that you have to use the protractor again, and you know the relation between the strike and the dip, which is 90°. So the dip direction is 35 north, 35 east, right? So we have to add 90° from here, so we'll get the strike direction. So 35 plus 90 will be 125. So you will be plotting the 125 which is here, right? So this is 35. If you consider it as 0, this will be 10, 20, 30, and 90 will be here. So we have to draw a line here. So this will be your first strike line. Okay, and in the question they are mentioned that there is an outcrop here, right? By our thumb rule, we remember that there will be an outcrop only when there is a strike and contour of equal value, and here you have mentioned as a contour value of 450, and there is a presence of an outcrop here. So this strike will be of 450, right? Okay, so what else to do? The next thing, is very simple. As usual, we have to find the horizontal equivalent, that is the spacing between the consecutive strikes, right? For that we have to use the dip formula, that is dip is equal to strike interval by horizontal equivalent into scale, and we don't know the horizontal equivalent, so we will just be replacing the dip with the horizontal equivalent. We will cross multiplying, right? So horizontal equivalent will be strike interval by dip into scale, and the strike interval is in the map which is equal to contour interval. So here in this map, which is 50-meter contour, right? So the strike interval will be 50, and the dip They are given in the question as 14 degree, and the scale which is equal to 1 centimeter is equal to 200 meter. So we had to convert this meter into centimeter, so that will be 1 by 20,000. Just by dividing and multiplying this thing, what we will get is 0.01 meter or 1 centimeter. And once again, we used to mention it as meter here because the contour interval is 50 meter. So that will be the strike interval. So that's what we are using meter here. So for our convenience, we are converting the meter to centimeter. So that will be 1 centimeter. So what we have to do is we have to place 1 centimeter, we will be pointing 1 centimeter gap from here in both the direction like this, right? So this is the horizontal equivalent. So we have marked the horizontal equivalent. The next step is we have to fill it with contours, right? So just like that, use the two set squares, make parallel lines from your main, that is the very first strike, right? So this is the very first strike, which is much longer when compared to the other. So we have to draw parallel lines just parallel to this line in both the sides. So we have plotted the strikes in this map. If you want, you can even further extend the strike in this point. You can continue it up to this, but for this map, this is more than sufficient as the values we will be filling there, and you will be finding why I am saying. So once again, by the rule, we know this is for 450-meter contour, right? And this is your true dip. If you are moving against your true dip, you know what happens. That will be in the up dip direction, right? So if you are moving in the up dip direction, the strike value will be increasing. So if you are moving from 450 towards the opposite to the true dip direction, then you will be having a rise of 50-meter in this side. So you will be getting these values like 450. So this will be 500, then 550, then 600, then 650, then 700, 750, 800, 850, 900, 950. Okay. And if you are moving towards the true dip, that is from outcrop P towards true dip, the strike value will be reducing in 50-meter, right? So if you are moving this side, you will be getting 400, 350, 300, 250, and go on. So we are having the lowest value of contour is 200 and the highest value of contour is 700. So plotting anything more than this contour value may not be meaningful, right? So for that reason, we are just stopping the contour up to 9. You started with 250 and up to 950. This is more than sufficient for this, for solving this map. Okay, so is that clear? So then what we have to do, as usual, if you have a contour same value of contour and strike, there will be outcrop. So here it is, already they had given the question. So like this, we have to find the same value of strike and contour. We have to point it out, and there will be an outcrop passing at that line. Okay, in this case, if you do the same thing like this, so you are getting points here, right? So this is your 550 contour, and here is your 550 strike, both meets here. So this will be first outcrop, and here is the 500 contour, and here is your 500 strike. These two meet here, so you will be plotting here the second point. Likewise, you can just plot all along, right? And remember, whenever you are drawing an outcrop, you have to start the outcrop from one end and you have to end it in the other end. So the outcrop will be starting from here. The outcrop will be crossing the strike and contour here, followed by this point, then this point. Like this, you have to draw. Okay. So just trace it just like this, and that's it. We're complete to the map. Is that clear? If you have any doubt, if you have any doubt, just mention in the comment section. I will try to make it more clear in the next video. So this is how we have to plot the outcrop in this map. So we are having same value of strike and contour, that is meeting here. So there will be an outcrop. So we have pointed all the points and we have just traced with your free hand, and this will be your outcrop for this map. Is that clear? And they are asked for the topography, right? And as you know, this is a v-shaped contour and having a center, a lowest value at the center. So this will be definitely a valley, and if the water is running, that will be running in this direction. Okay. And in terms of outcrop trend, as you know, in the previous map itself, we are having the same, right? So due to just following the v rule, you know, the true dip is in northeast direction and the slope is in southwest direction. As you know, dip and slope are in opposite direction, so the V of the outcrop will be pointing upstream. Okay, so that is same as the earlier. But you found one difference from the previous map, right? You remember? So in your previous map, we had used 3.1 or some centimeters as horizontal equivalent, whereas in this map, we are using 1 centimeter as horizontal equivalent. Do you remember? Just recall it. That is due to that. Do you remember this video lecture, that is relation between strike and dip and outcrop, all those things? If the formation is horizontal, you will be not having any strike passing through this, as every line you are drawing on the formation, that will be a strike, right? If you are having a gentle dipping beds, you will be having a less number of strikes and the spacing between the strike will be more, right? And if you are getting more uh, steeply dipping formation, then the spacing between the strikes will be lesser. And if it is a vertical formation, then we cannot draw a dip direction. All the strikes lie in a same plane. Is that, do you remember, right? So if you just cross check with this previous map, the dip amount of the previous map is just 4 degree. So the spacing between the strikes are very high. Whereas in this case, if that you can see the dip is 14 degree, as you know the dip is higher than the previous one, so the horizontal equivalent is lesser. Is that clear? So that is what I want to explain to you with this map. So with this, I am just completing this map, that is map number 7. Thank you.